Hi everyone, are you able to see my screen and hear me clearly? All right. So, okay, great, great. All right. So, to ask questions, use Q&A window, and to reply, please use chat window. I'm Sandeep Giri. I'll be the presenter for this session. Feel free to ask questions. This session is going to be recorded, and the recording will be made available to all of you. Also, this session is of 3 hours, and we're going to go through the entire discussion on the machine learning. We'll begin with basics. This session is very, very general, though there are some parts which are a little bit more technical. So this session serves as introduction to machine learning for most of the audience. Great. All right. So, okay. So I'm going to switch between Q&A window and the chat. To respond to the questions, please use chat. To ask specific questions, use Q&A window. I'm going to stay focused on the Q&A window. While others are joining, please feel free to introduce yourself using the chat window. All right, feel free to introduce yourself, though I may not be able to read it now, but we will go through your introduction uh, after the session. There are going to be more than 100 attendees. All right, so let's start. A question from Rajit is, will you be covering deep learning introduction as well? So we will just cover the basics of neural network, and the deep learning, which involves multiple layers of neural network, will not be covered today as such. All right. Great. Great to see your introductions, and I'm thrilled to go through the session and give you an introduction to the machine learning. All right. Those who have raised the hand, please ask your questions using the chat. Except for me, the presenter, everybody has been muted. You can either ask questions using Q&A window or respond to general messages using chat. All right. Great, great. So the question from Robin is, what are the main differences between machine learning, AI, deep learning, and NLP? By the end of session, these questions will be cleared. All right. By the end of session, these are the questions that get cleared. In case it's not clear at towards the end, I would love to answer this again. Will this course be taught in R or Python? It'll be in Python. Okay, great. So let's get started. All right, so Welcome to the session on Introduction to Machine Learning. First of all, I would love to introduce you all to CloudX Lab. So at CloudX Lab, we are making learning fun and for life. For making it fun, we have videos, we have quizzes, we have hands-on, and we have projects, and we have case studies based on the real life use cases. The the objective of you saw one part in the middle that's called hands-on. So hands-on assessment is something that we have designed, and it's far different from what mm, there has been a way to evaluate. Here, the objective is to make sure that you do the things in the lab and get it evaluated automatically. So say, for example, the way it works is you will have a problem statement and you will have to do hands-on as per the problem statement, and then automated assessment will happen. Say, for example, this is one of the simple case where you have a problem statement. The problem statement says that you have to log in into CloudX Lab. Uh, this is the simplest assessment. And once you are done, you click on I'm done, please check, and then it automatically checks whether you have really logged in or not. Now here is another assessment. On the right hand side, you have Jupyter window. What is Jupyter window? Jupyter is kind of an editor in which you write the code, press Shift Enter, and when you press Shift Enter, you will get the results. Okay, so you can do the incremental programming. You can do this you can keep on writing small code and keep on trying it out, and all of this from the browser. All right, that is Jupyter. So what we have done is we have connected the Jupyter and our exercises in the same window. On the right hand side, you will see the Jupyter, in which Jupyter is like notebook or workbook in which you keep on working. And on the left hand side, you see the challenge. Like here, the challenge is really simple, saying that define x as 10. Okay, so, and once done, please check. So once we have defined x as 10 from the right hand side, it has said to us, good job. That means it has successfully checked whether you have defined x as 10. Okay, now the objective of this course, the course or specialization that we are going to start today, the objective is to learn machine learning, entire machine learning. It involves deep learning, it involves basics of machine learning, as well as it involves the foundations of machine learning, in which we learn the basic tools. So the objective is to learn machine learning with Python, specifically the scikit-learn. There is a library called scikit-learn for basic machine learning, and then move over for deep learning to TensorFlow. So that is the specialization. It is really very important to learn the deep learning as well as machine learning, because you can't really learn deep learning without machine learning, and you can't learn machine learning without having the knowledge of Python and the foundational tools. So this course is sufficient for all who are looking to upgrade their career into deep learning as well as machine learning. And this course is fairly deep. This course is fairly deep in the sense that we will go into the work that has been done in last years, and we will also learn how to make tools like how to make the systems like translation, like Google Translation. All right. Also, we will also the whole course is project oriented. We all the examples, all the theory, everything is around the problem statements of the projects. Okay, so we have around 7 to 8 projects. So I'm really happy and excited about this course, and this course or specialization is probably one of the best in the industry as of today. All right, so this is one of the best available course available online by live instructor. and I will be the instructor. I'm Sandeep Giri, and I graduated from IIT Roorkee long back. I have largely worked on the large scale computing. I have mostly worked on large scale computing in my career, on my career, and I started my career at D. Shaw. D. Shaw, you may not be knowing what is D. Shaw. D. Shaw is a finance firm, and D. Shaw is known for its computing infrastructure. Before Google and Amazon, D. Shaw was the big data company. Why I would say big data? Because the term was even not coined when D. Shaw was there. So at D. Shaw, we had a cluster of 10,000 node, and we were doing lot of different kind of computing, genetic programming, machine learning. Used to call numerical analysis, and then we had even the problems involving petabyte data. So at DSHA 2002, we had 10,000 node cluster, and it was one of the biggest infrastructures at that point of time. Then I founded a company called Tbits Global, where we built a document management system for large scale systems. And then worked with InMobi, and there, using 200 terabyte data, we built the machine learning model for the recommendation engine. After InMobi, I worked with Amazon detail page. We did many innovations. All right. So this is about my background, and I'm a software engineer at heart, and I love explaining technologies, and that's one of the reasons why I've started CloudX Lab. The objective is to help to help everyone learn big data and machine learning technologies. All right, to help everyone learn big data, AI, and machine learning based on my practical experiences. All right, so before we start the machine learning part, let me just try to answer your questions. Okay. So there is a question from Bintao. What is the relationship between big data, AI, IoT, and blockchain? Which one is more challenge, and which one is higher demand in the job market in 2018? All right. So there was a similar question. Although we will learn all of these parts by the end of it. So big data is nothing but being able to process really humongous data using many computers. So big data is distributed computing, and machine learning and deep learning is about giving the data, figuring out the predictions. Okay, you will learn that part soon. AI is the definition of AI is very objective governed. Okay, meaning anything that mimics the human behavior is AI. Now there is IoT and blockchain. IoT is basically connecting components together, sensors together, and blockchain is basically a way of having the distributed trust. Okay, so that's as brief as I can. And which one is more challenging? It's very hard to quantify that, and each one has its own challenges, and each one um, has its demand. And these, specifically the big data and AI, they both overlap with each other with respect to many aspects. All right. A question from TensorFlow. A question from Christian is that is TensorFlow better than PyTorch? So PyTorch has its own advantage, while TensorFlow has its own advantage. PyTorch is actually good framework, but TensorFlow is far more customizable and far more detailed, and you can achieve far more modular computing with TensorFlow. While PyTorch is for getting things done quickly. All right, we will go into those details probably later. A question from Robin is, will there be machine learning use case topics, projects involving anomaly detection? Will there be also examples? All right, so anomaly detection, yes, we will go through that. And so far we were only working on, so these two examples, let's see if we can include the anomaly detection, because we had anomaly detection, but in that the examples and project that we covered is how to reduce the dimensions. Okay, so will there be also an example of machine learning use case that involve blockchain? So far not, but we can figure out something. If you have some ideas around it, feel free to reach out. All right. Okay, great. A question from Siva is, much impressed with your technical background. Curious to know any patent on these areas against name. So I would love to explain to you that I personally have not been very fond of patents, and even at D Shaw, InMobi, or Amazon, even at my own startup, I've not filed for patent, though my teammates and other people have filed for patents, but I don't. All right. So it's not, I'm not big, because anyway, if you look at today's world, the world is open, and world is open in the sense that probably everything that I'm going to teach here today is available in public, in the public domain, right? So the patents are not something that takes humanity step forward. So one of that reason that I strongly detest patents is that. All right. What is the impact of machine learning in automotive domain? It's going to be huge impact. Let's just talk about it in a while. Okay, difference between automation and AI. Yes, you will see it soon. You will see it soon, and I would love to answer that question. All right. So before further questions, let me just walk you through an example where we will learn what it means by machine learning by the way of seeing the video of a live example. All right, so I'm going to walk you through that. That is the best way to that's the best way I've learned to define what is machine learning. All right, so let's walk through the example, and you will yourself know the difference between automation and AI. All right, great set of questions, and I would all right. So this is the standard classic definition, not that interesting definition of machine learning. So the machine learning is field of study that gives computers the ability to learn without being explicitly programmed. All right. We will revisit this definition after this example. All right. So let's understand it with a real use case. Now, how many of you have played Mario? Feel free to raise your hand. Wow. Almost everyone has played Mario. Wow. Great. So almost everybody has played Mario. So please feel free to raise your hand if you have played Mario. Wow. Great. Now the next question to all of you is, did you win the princess? Wow. There's so many people who have won the princess. Great. So 22, 23 people have won the princess. Wonderful. So now next question is, do you think that it can be automated? Do you think it can be automated? As in, can playing Mario be automated in the sense that just like the way you learned Mario, can the computer also learn Mario? All right. So let me take a look at your hands. All right. So four people said, okay, 20, 20, 30 people believe that it can be automated. All right. So let's take a look at the example of Mario being played by computer. So, so the way it was automated is that Mario was run in an emulator. Those who are still interested in learning Mario, they can actually download a NES emulator and load their Mario game into that emulator. All right. So I have actually recently played Mario in the emulator. So you can also give it a shot. Now, the way it happens is that you launch this software called NES emulator, and inside that you load Mario, and then you can play Mario. So in the same way, for software to be able to playing to for software to play Mario, this is what was done. It was run inside emulator, and the software was pressing, or the program or the bot was basically pressing the keys randomly and observing what happens to the score. Okay, the program, or the bot was the program learns to play Mario. It observes the game and presses the keys randomly in order to maximize the score. So the person who you see on the screen is Tom Seven. He is the one who automated it and made it public in the beginning into a long back. So that brought in a revolution in the day in the domain of machine learning from the fun perspective or practicality perspective. So the objective is, after hooking the Mario into the emulator, and the program basically learns to play Mario by observing the game, pressing the keys in order to maximize the score. Let's take a look. All right, what you see in the screen is Mario behaving like infant, right? So the program is pressing the keys randomly, you can see, crazily, and the Mario is not going anywhere. But the program is learning from the experience. So now, after a couple of weeks, this is how it's going, though it's facing backwards, no idea why. And you can see that it's not really great, but it's able to move. After a few more weeks of self-learning, this is where the program is. So you can see that it doesn't have too much difficulty in moving around, is stomping the Goombas. It has learned all of this by itself. Nobody has told it about the gravity, about collision, about the Goombas, and about the colors or the objects. Okay, so you can see that it is able to cross the hurdles. Now you're going to see this amazing part in it where it's going to do something really amazing. Okay, so stay focused. So here you see it's about to exploit really good, a big bug in Mario. What was that? The Goomba was falling on it, and the moment it started falling, moves a little bit downwards. The game thinks that Mario had jumped on Goomba while it was the other way around. So this is something amazing about the machine learning, that it figured out something which we never did. Now you're about to see something else. See, no idea how did he do that. So the same game, the same program was able to play other games, but it wasn't able to perform very well in many games. So it kept on pausing the games. It kept on pausing. It kept on pausing the game and because that was the only way to retain the score. Just so it kept on pausing the game, just like in the end, if our siblings or our cousins could not win the game against us, so they will just spoil the game and run away. So in the same way, the program kept on pausing the game so that it doesn't lose. All right. So this is an example of machine learning, where the plays computer learns to play Mario and other games without any programming, without any programming. So so basically here this is the most important part. Had it been just the automation, we would be sitting and writing the rules about what to do when you see a Goomba, what to do when you have to jump over a tunnel or something like that. So here we are not programming at all. We are not programming at all. We are letting it observe and learn from the environment what to do next. All right. A question is, to make this program learn any other game such as Pac-Man, do we need to write new rules per game, or just hook it to the new game and let it play for a while? Just answer in the chat, one or two. To make this program learn any other games such as Pac-Man, will we have to write new rules as per the game, or just hook it to the game and let it play for a while? Yes, the answer is two. So you just hook it to the new game and let it play for a while. Okay, and this is how it'll learn to play any game. We don't have to write the rules. We don't have to code for every different game. That's the difference between automation and AI. In AI, we don't teach every rule. We only give it target and let it figure out by playing around. All right. All right. Now imagine doing the same thing for the life, gathering data. The reason why the program was able to play Mario so effectively was it was able to gather the data. It was able to play Mario again and again in order to get the data. And because of the efficiency of algorithms, it was able to figure the next possible steps to take. The same could be possible for life if we are able to gather data and hence automatically solve problems. So, so there are many applications of machine learning, and you see in today's time there are many more applications of machine learning. All right, let me just try to answer your question. A question from Balaji is machine learning a part of data science? Yes, machine learning is part of data science. Actually, the two terms are quite overlapping. Data science also involved the manual way of churning data, visualizing data, and manipulating data. So data science is a big term, and machine learning is one part of it. Machine learning is a branch of artificial intelligence where we learn to program computers to learn automatically. How does machine learning guarantee or assure accuracy in order to avoid bias, result/output? A very good question, Robin. So As a matter of fact, most of the machine learning is all about removing the bias and avoiding too much of memorization. So basically, we will learn that there will be many terms that you will learn as part of the course. What is underfitting, overfitting, what is bias and variance. So when you try to avoid the bias in your machine learning algorithm, it ends up having too much variance. So we will learn that almost every algorithm need to be need to be need to be regularized in order to avoid bias. Otherwise, the accuracy will not be there. So, like for example, in neural network, there is something called in neural network there is something called dropout. In the say linear regression, there is something called there is something called regularization by adding the extra term in the loss function. And similarly, in decision trees, we try to enforce enforce the height of the tree so that it does not memorize everything. So we will learn those things in detail. And if you see the course, almost every algorithm that we learn, we will focus on understanding how to avoid bias. Okay, how to avoid bias or memorization, overfitting and underfitting. All right, bias and variance. All right, a question from Sayed is, okay, a question from Sayed is that IBM's SnapML is faster than TensorFlow. So what exactly is the difference between the two? All right. So I'm not sure how, on what basis that has been stated that IBM's SnapML is faster, but TensorFlow is open source. The entire world is using it. And using TensorFlow, you could create any kind of algorithm. Okay, so that's what we are using. So the entire course is constructed, and I'm very confident about the TensorFlow's capabilities, that even if a new framework would be coming, that would be mostly inspired by TensorFlow. All right. So it's actually so most of most of the tools or the frameworks that you will learn in your career, they come from one another. So so if you learned C, it'll be easier for you to learn Python. And if you learned Java, it'll be so similarly, if you keep on going from one to another, there is what I would suggest is that the technology like TensorFlow, which is widely adopted, if you learn that technology, it'll be really easy for you to move around to another frameworks. All right. And the course is designed, this course is designed in a very generic way so that so that you will get the hang of the overall idea, and you will also learn how to implement that idea using TensorFlow, as well as you will know how to implement it using say scikit-learn. So you will be able to switch tomorrow by yourself without any extra effort. All right. A question from Robin is, I'm curious how he made a bot automatically press the keys for Mario's action. Is it logically? Yes, it is based on the past history, based on the machine learning. It was pressing the keys using eh, using the emulator, right? We could send signals to the emulator. A question is, why should we enroll for a paid course at this cost, right? While we have abundant resources online too. That's correct. So there are abundant resources on YouTube and everywhere on internet, right? The biggest challenge that why did I launch this course in first place? It's a good question, though you have asked it anonymously, but so it's a good question, and let me answer this. So I have seen many of my friends, many of my students earlier that they're not able to complete the self-learning course. Self-learning course remains in their agenda. They're not able to move, and they basically other priorities take over, and the machine learning remains on the back seat. So the other reason for this is that learning machine learning is a bit harder. It's a harder discipline. So it's important to have a committed sessions. So if there is a live session like this one, I'm sure you will not like to miss it. And there are many candidates from my other sessions. They can for sure, uh, for sure, give the testimony that the live sessions are something that you will not miss. That's the first thing. Now, second is that a bigger reason why people abandon the machine learning courses is that they get doubts. So let's say you got doubt at one particular time and it did not get cleared. So you will go on the internet, try searching, and then you will be lost forever. So that is the second reason why the live course works. And this is a very important discipline. If your doubts do not get cleared, you will end up either memorizing or skipping many topics. So this is the reason why we have created live course. Also, we found that the courses on the internet are too sparse, as in there is there's just too much of information which is actually confusing people. So we basically sat down and made a list of things, the minimal list of things that are required to learn to solve even the hardest problem in using machine learning. All right. So that is the idea behind the course. We have kept, even though the course is really huge, but we have kept only the things that were really required. So we have removed and only kept the part that is really required to solve hard problems. Okay. A question is why we don't need new rules, because in case of Mario, it was learning the rules by itself. All right. I hope I was able to answer your question. All right. So a question, thank you, Robin, for adding. Nothing compares to live session where the mentor is highly capable of addressing all the queries and help you when you get stuck and need guidance. All right, so thank you. That's a good testimony for us. And you could take a look at our testimony on the on say Quora or Facebook or other places. So you will find that there are many many people who are happy with our sessions. So yes. All right, let me move ahead. So there is somebody was asking about the IBM's SnapML. So I would like to stay because I have not used SnapML yet, so may not be able to comment. All right. Is there a relationship between cognitive computing and AI? Is that AI that you mean? So yes, cognitive computing is basically on the similar lines as machine learning. And these are basically different terms for the artificial intelligence part. All right. So thank you, John, for saying that. Let me also try to figure out how to resolve this problem. So all right. So we will talk about the SnapML and TensorFlow aside. So in this course, we are not really promoting Python or TensorFlow or scikit-learn or any other thing. Here, the course is about learning the general concept to an extent that you can write your own algorithms. Okay, because that's the only way to be able to solve your problems. Because what happens is if we are just memorizing algorithms or just trying to know that how to do this or that and so on, you will be only able to solve few counted problems, right? But what is required in general in the machine learning is looking at a problem, you should be able to figure out that yes, this can be solved using these kind of machine learning techniques. All right. First, figuring out whether to code it or whether to use machine learning for this is a very, very hard decision. And that would happen only if you are learning in the right way. Okay, so it's a very important aspect of the computing to be able to figure out that this is something that can be automated, this is something that cannot be. All right, and to achieve that you should be able we should be able to achieve it once we have gone through the course. All right, so moving ahead, now question is the example of the Mario that you have just shown, how did it gather data every time? I mean, the pathway from infant to expert mode. So basically, the whole screen that you saw, the whole screen was being captured by the algorithm, and it was basically keeping track of what happened last time. So that's how the pathway from infant to the expert happened by playing again and again, gathering the screenshot of gathering the images on the way. Okay. All right. So yes, John, I'll keep that in mind. So do you say that you can use Mario AI to Beckman and not trial? Yes, that's right. So the goal for both could be different. The goal in case of NES, it's basically maximizing the score. So as long as it knows how to pick the score from the game, the rest of the things it can figure out by itself. Okay. So the good move for Mario and Pac-Man will be different, right? Does it mean, yeah, same question. The objectives, the criteria is to use the score. The score position on the screen could be different. That's the only difference between Pac-Man and Mario. And it'll basically keep on trying all possibilities and learn from it, and then uh, become expert at it. All right. Okay, so this question has been answered. And did the data grow dynamically? Yes. Data grew dynamically because it was playing it and observing what's going on. All right, so a question is the NES game like Mario created in Python programming? Not really. Basically, the Mario was launched in NES, the simulator, and the program that is a C++ program, by the way, in the example, that program was basically observing the simulator's memory. Prolog is another language. I'll keep a lot of questions aside. Are you covering ML deployment models? Yes. End-to-end machine learning is what we'll cover in this course. All right. Is it required to know statistic background to learn machine learning? What level of programming knowledge is required to do machine learning? So good question. So let me just answer this question because a lot of, is my voice breaking? You can answer using chat. All right. So it's only breaking for 1 or 2 persons. Okay. All right. All right. So, okay. Okay. All right. So since there are many no's, which means that means everything is all right. Okay. So great. Great. Now, is it required to know statistical background to learn ML? What level of programming knowledge is required to do ML? All right. So there are two questions in it. First one is statistics and other is programming. So both the parts, statistics as well as Python programming, we will teach you in the course. We will have previous courses, and trust me, it's not going to be a problem at all. Okay, the basics of statistics is what you require, and we will, wherever it's needed that to know statistics, we will teach you. All right. So the way we are going in this course is we start with the project, and whatever is required to learn the concept, we go back and learn those concepts and come back to the project. So that is something different we are doing in this course. We will start, the second session after this is going to be end-to-end project. Even though you have no clue about what is machine learning, I'm sure that by the end of the session on end-to-end project, you will all learn that. All right. So whatever is required for that, we learn during the course. Okay. The only thing that is expected in this course is you should have done a bit of programming in past. So you should know what is a programming and how does a programming look like. All right. Um, it'll be great if you have a bit of maths background for the course, but we will teach you whatever is needed in the course. All right. When the program learns from experience where and how the data is saved, how is it retrieved? So basically, every framework provides its own way of saving and retrieving data. That too we will learn as we go ahead. All right. So there are two parts to the data. One is called model and other is called input data. And we will understand how to save or retrieve both of these. Okay. Yes, you will all get the recorded session of every live session we have. Can we move a bit faster? Yes, I want to move faster. Just that it's important to answer a couple of questions, and it'll be great if all of you cooperate a bit in answering the question, because what I believe is that our sessions, live sessions, are done so that everybody gets their questions answered. Okay, we are okay in we are okay in extending the course. Okay, though it's very costly for us, but we are okay to extending the course if uh, if we have to because if there are more answers, so it might take more time. All right. Yes, I will. Let's just move ahead. In case if we need recordings of yes, you can reach out to us. All right. Great. Great set of questions. If emulator was used for Mario ML years ago, what tools are being used today to teach machine to solve these problems by itself onwards? Good. Very good question. So emulators, so earlier it was hard to use the emulator because it's a lot of work there. Nowadays we have things like OpenAI Playground, which you can use via API easily without having to install emulator and other things. Let me just write in the chat. It's called OpenAI, and we will be using their gym. Okay, that's the one we'll use in the machine learning course to emulate what we did to Mario. Okay. All right. Hypothetically, you can do many things for ML, but actually it's a program you need to design. That's right. That's right. Okay. At least at least should the program be taught about various keys for the emulator? Yes, it should be told that you can press these keys. You have up arrow key, down arrow key. Those are the common keys for the whole emulator. Those are the only things that you have to teach the program to press. Okay. I'm new to ML. I'm not good at maths. How can I do better? You can basically go through this course probably, then it'll be better. All right. So when you say course, are you referring to this? I'm referring to the course specialization of CloudX Lab. Okay. Is it possible to apply scalar programming knowledge in our machine learning class? Okay, so yes, there are actually just That's a hard question to answer. So there are many libraries available in Scala for machine learning. So you will be able to apply any programming language knowledge in order to solve machine learning, what we learn in the class. Okay, these are very important questions. All right, let's just, I would say that let's just try to answer these. Probably all of you are having similar questions. It's just that we are not asking. So, and these are the foundational questions. And if these are not answered, probably most of you will lose interest. Okay. All right. So stay with me. I'll just try to answer questions really quickly and then move ahead. All right. Question is, what is the order of learning? Big data, machine learning, AI, deep learning. So big data and machine learning, those are kind of independent track. To solve some problems, you need only the knowledge of distributed computing, that is big data. For some problem, you need the knowledge of machine learning. While the order is, in case of the machine learning, deep learning, and AI, deep learning depends on machine learning, and AI depends on deep learning. Okay, so AI depends on deep learning depends on machine learning, while machine learning doesn't depend on big data, and big data does not depend on machine learning. So that is the order. So I would say that you can independently take either of the courses, either big data or AI, and so on. Okay, so great. Is there obvious criteria when one should train new neural network, like for Pac-Man or Mario, versus fine-tuning existing models? So yeah, so that's a hard question. And what you do is you basically try using the existing models. If those are working well, if the existing models are working well, you use that. If they are not giving you good performance, you fine-tune. You basically train a new neural net. Okay, so we will learn about pre-training concepts like pre-training and more during the course. All right, during question is, so far this talk we spent 45 minutes and no detail have been discussed except for very high level fundas. Looks like to me is this advertisement of the paid course, and meetups I used as ad platforms, and I feel that I have wasted my morning. Yes. So I would like to tell that I mean, let me answer this question. So I would like to request all of you that since there are many people in this course, it's an introduction to machine learning, and people come here to get their questions answered. So have the patience and try answering the questions of each other. So that's the only way we'll be able to learn. All right. We cannot learn by just hurryingly. It's not something like we can eat quickly. Okay, so I would request you to have patience and cooperate with others. All right, so great. For most of the questions, how is the infrastructure needed for machine learning? We'll talk about this, okay, today. And yes. So today, basically, we're going to cover this is the introductory machine learning class. So if you are already good with machine learning, this today's session might look very elementary to you. All right. Okay, let's go ahead. So I'll answer these questions probably after a couple of more topics. All right. So keep in mind that this today's session is going to be fairly introductory, while remaining course is quite deep. And so you'll have to be with me if you have already gone through the introduction of machine learning. All right. So as of today, there is a tsunami of machine learning applications. Say, for example, self-driving cars on the road, or you can see the recommendations given by Netflix, similar thing we did at InMobi as well. And then Amazon product recommendations, those, they don't look like machine learning applications, but they are machine learning applications. Then the accuracy of the results in Google search. Now, this doesn't look like machine learning application, but but a lot of it is happening by the use of machine learning. The way you see um, breaking the PC world into PC space world, as well as the results that you're showing is basically observing which results are being clicked and so on. So it's taking the feedback from users. So it's extended form of giving recommendations. Speech recognition. Long while ago, all of these branches were different, even at Google and Amazon. The image processing, the voice recognition, and so on. All of these branches were separate departments. And today they all have merged into a single department. Now, why that happened is because the machine learning has been proven to be super successful in almost all of these domains. Okay, so we will learn about in one of the projects we will learn about how to do the translation from one language to another as part of this course, as part of something called reinforcement learning, or as well as RNN. We will learn the translation as part of recurrent neural network towards the end. So in order to achieve intelligence like the way playing Mario, we need two things. One is gathering data, and other is intelligence. With respect to data, we need to collect, clean, and process. For collecting, we need all kinds of IoT devices. And IoT devices today, or any devices, have become cheaper, fast, and smaller. And on the other hand, the connectivity has become really highly available. So collecting data has become easier. And processing, again, processing has also become possible with the advent of many things. The first thing that has happened is the distributed computing. All right. Another thing that has happened is the GPU based computing. So I would like to explain a couple of ideas here. First one was, what is parallel computing? Parallel computing is doing two things parallelly. That's called parallel computing. Now, how can you do two things parallelly? Either using multiprocessor or using multiple computers in the network. If you are using many computers in the network, then we call that distributed computing. So distributed computing is groups of networked computers interact with each other to achieve a common goal. All right. And the second form of parallel computing is the multi-core or GPGPU, general purpose graphics processing units. So generally we refer it as GPU. So the parallel computing could be in the form of multi-core or in the form of GPU. So multi-core means this is something that we have all of the computers that we right now have do. It has many processor, it has many cores like four dual core, quad core, and so on. And then there are graphics cards. Those are generally referred to as GPU. Graphics cards are known to perform graphics operations, a lot of mathematical operations, and the scientists figured out that it is very much possible to do machine learning on GPU. Okay, so parallel computing can be done on multi-core or can be done on GPU. GPU are many processors in a single unit, that is GPU. All right, I'm just going to give you a quick overview. I don't have to go into more details. So when you need to handle huge data, generally the distributed computing is far better. If you have to do things really fast and there is a lot of communication required between processors, then you either use GPU or you use multi-core. If you need to do a lot of mathematical computation, such as doing high-end deep learning, then the graphics processing is what is used, the GPU, and distributed computing is being used, but it is not found to be much effective if there is not much of data being processed in parallel. All right. The tools in case of multi-core, there are many tools for multi-core. Some of them are, say, MR and Spark. And in case of GPU, you will have to use Keras, TensorFlow, Caffe, or Spark. And Spark's GPU way is still under experimentation. Now, with respect to distributed, the Hadoop MapReduce and Apache Spark is being used widely. So out of Hadoop MR and Spark, the Spark one is the one that is the most popular in order to process. So we can do the the parallel processing by the way of using many computers or many processors simultaneously in the same computer, or maybe both of them distributed as well as the GPU together. All right. So this was basically in order to answer this. So collect, clean, and process. For processing data, you can use parallel computing when the data is really huge. All right. Now let's try to compare the approach for machine learning as it was before and now. Okay. Question is, how do you write a spam filter? How do you write a spam filter? Let's take a look at the traditional approach. The traditional approach was you study the problem, you write the rules, then they evaluate those rules, analyze the errors, then again you go back to studying the problem and then write the rules and evaluate. If if it is performing really well, you launch. Otherwise, if it's not performing, then you evaluate again. You analyze errors again, and then you go study the problem and then write the rules. So this is the traditional approach. All right. In this, the maximum time is spent in 1 and 2. So we keep on writing rules and we keep on studying the problem. Do you see any problem with this? Yes. So there are quite a few problems with this. One is solving spam filter is not a trivial approach. It's not trivial to solve spam filter. Program is likely to become a long list of complex rules. We will end up writing a long list of complex rules. It's really hard to maintain. Such systems are really hard to maintain because you have complex set of rules and those becomes conflicting rules, and you have to keep updating the rules. The moment the spammers know that you have created such a rule, they'll find another way to skip that rule. Okay, so if the spammer noticed that we have figured out that if spammer noticed that we are blocking emails containing for you, then they might start writing for you, right? So essentially, it'll become a war of rules. On one end, you will create rules. On the other end, the spammers will trump the rules by making their new creative ways. Okay, so we'll have to keep writing the new rules forever. This was the traditional approach that we always used. Now, the machine learning approach is that we study the problem, we train ML algorithm based on the data, evaluate the solution. If it's working fine, then launch. If it's not working fine, then again we study the problem and train ML algorithm. So instead of we writing the rule, we train the algorithm and build the model in order to do the spam filtering. This is the biggest difference. So instead here we are having the train ML algorithm part. Instead of this, we were actually earlier writing rules manually. All right. So spam filter based approach on machine learning techniques automatically learns which words and phrases are good predictors of spam by detecting unusually frequent patterns of words and so on. So the program will be much shorter and easier to maintain, and it will be more accurate than the traditional approach. We can further automate the process of updating the data, training the ML algorithm, evaluating and launching. This we can automate so that our model keeps updating automatically, and it keeps giving the results more accurately and updating itself. All right. So this kind of ML approach can not only help us in making a spam filter better, but also can help us learn that can by inspecting the algorithm, we can figure out that that what kind of words are spam. So it can help us understand the behavior of spam better. It may also reveal unsuspected correlation or new trend. Just like in case of Mario, the program was able to figure out a bug in the game in order to exploit it. So that was something uh, done, right? So that was something done in Mario as well. So it figured out the unexpected or unsuspected way of winning the game. Similarly, when you are training your algorithm to do classification of email as spam or not spam, it may come out with really creative solutions. All right. It basically, in all, the ML approach helps us better understanding of the problem to the humans. Okay. So this is what we're talking about. So we study the problem, train ML algorithm, create a solution, inspect the solution, and learn from it, and then iterate if needed. All right. So, all right. So let me just go over questions quickly. Can you please let me know what is covered in the webinar? So we are going to cover basics of machine learning, AI, and then we're also going to talk about deep learning. All right. So can you give us applications that being used in yes, that's what we are going to do it. Okay, don't worry. A question from uh, V Iyer is, doesn't AI ML DL depend on ability to handle big data, as in high volume even? So, so there are many very interesting ideas today that even if you don't have big data, you can always borrow the pre-trained model from somewhere and use that to do the predictions or improve from there. Okay. So it's not always that we need to have the big data in order to solve our machine learning problems. You can always borrow the model or use some public data in order to do machine learning. A question from Robin is, in Google Search AI, does accuracy only refer to what previous other people typed? Yes, that's right. That's right. And so basically, they use the knowledge that you searched for this keyword and you went onto this page and you stayed this much time on this page, or did you come back and uh, did click on the search results. So they do all of that in order to improve the search results. Okay. Beside the speech recognition, I would like to add a technology like Cortana, the HP virtual agent, which ML and AI powered. Yes. Okay, yes. That's also basically part of speech recognition by Microsoft and I think HP. Okay. All right. Silpa's question is, isn't it that humans has to evaluate the outcome? So what we do is we create test cases whereby the outcome is automatically evaluated on test data. Okay. A question from Robin is, it appears to me that besides spam filtering, MLDL and AI is also applicable to, yes, almost everywhere there we find it complex to make rules, and we can use machine learning. So even if ML learns from data, it must be forming some rules also, I believe, based on which decisions are made. That's correct. All right. So I think this is answered. So many times, I totally agree that AI ML depends on the ability to handle big data, but many times we don't have big data. In those cases, what we do is we buy or borrow or use somebody else's models. Okay. So we learn this part how to use the pre-trained model as part of the course. Okay. So question is, what happens if an unseen situation comes which has not been seen previously? That's right. So the true learning is not about recalling what they have seen in past, but being able to take the right decision, right? As we saw in case of Mario, that it it basically learned from the past by playing again and again, and in order to win it, instead of just doing things which were existing in past, but actually taking the right decision. Okay. Can spammers use ML to get around spam filters? They would definitely compete in the same way. All right. All right. So yes, so it's a good question that spammers can also use the machine learning, but they would also require data extensively about what emails are being blocked and what emails are not. Okay, so they too can use the same way. All right, a question is, how can we evaluate whether our ML hypothesis is correct or not? Generally, we break down data into two parts, test data and training data. We train our algorithm on training data and test it on the test data. That way, that's the standard way of checking whether your algorithm is working well or not. All right, so let's move ahead. So I think most of these questions will be answered and have already been answered. Great set of questions, and let's move ahead. Now, all right, so the next question that we always have so far what we have learned is what is machine learning? And we also talked briefly about that we can do machine learning if we are able to either have the data or we can also use pre-trained models. Okay, so for gathering the data, processing the data, we need big data tools, the distributed computing as well as GPU. And now let's move on to the AI. So what is AI? AI is the intelligence exhibited by machines. The artificial intelligence is the intelligence exhibited by machines. So this is a very, very hard definition because intelligence is subjective. Therefore, it's very hard to define AI. Let's take a look, right? So let's break down the definition. The theory and development of computer systems to perform tasks requiring human intelligence, such as visual perception, speech recognition, decision making, translation between languages, and so on. So we have been obsessed with creating the human-like creatures since long time, and even in mythology. So in 1956, John McCarthy, in a workshop at Dartmouth College in New Hampshire, along with Marvin Minsky and others, defined the term artificial intelligence. And the term that was defined by them was that any program which is able to achieve these five sub-objectives, will be considered to show the artificial intelligence. So these are the five sub-objectives that need to be met in order to be called it as AI. Okay, so or in other words, you can say that in order to create artificial intelligence, we should be able to do these five, right? First one is representing knowledge. We should, our algorithm should be able to understand and classify terms or or things in the world. For example, what is a computer, what is a thought, what is a tool, and so on. So languages like Lisp were created earlier for the same purpose, but that did not solve the purpose. But today the programs like Word2Vec and there are many other tools, they represent the definition of words far more precisely as compared to anything else, thanks to humongous data. Reasoning is the second component of AI was reasoning. Reasoning is like playing puzzles, proving geometry theorems, and diagnosing disease. Third is navigate, being able to move from one point to another. And because navigating is a very hard thing, how to plan and navigate in the real world, how to locate the distance, how to pick the path, how to pick the shortest path, and how to avoid obstacles and how to move, as in what motor to use. Then is NLP. NLP is natural language processing. How to speak a language, how to understand a language, how to make sense out of a sentence. Those are all part of NLP. In NLP, what we learn is how to convert a word or a sentence into some real representation which can be understood and translated. And so there have been a lot of research on this. One of the topics we will cover NLP, NLP as in the underneath machinery required for NLP. The next sub-objectives of AI was perception. Perception is not about only seeing as in visual perception. It could be based on sound, touch, smell, or it could be based on the infrared radiations. So if you are aware about the photo that you see in the screen, it is from Microsoft Xbox. And Xbox recognizes people, how well they are dancing in front of it by using their Kinect device. And Kinect has 3 cameras. Those cameras do the perception, but along with those cameras, the Kinect has something called infrared sensor. So it differentiates between sofa and human, or chair and human, based on the infrared, and then it uses the camera to identify whether a person is dancing well or not. Okay, so the perception could be based on visual, sound, touch, smell, or infrared proximity, or there could be many other similar uh, perception dimensions. Then this is something that we have been arguing, and this is something a lot of us find magical, that they said in that conference, John McCarthy said that if previous 5 things are met, if the previous 5 sub-objectives are met, then the program will automatically start showing the other form of intelligence, such as emotional intelligence, creativity, reasoning, and intuition. So these will be automatically shown. Now, this is an interesting part because we always thought that this is the only intelligence. This is the only definition of intelligence. So now this was something hypothetical, but this has been proven right. You could see in case of Mario, the program was able to show the emotional intelligence, like pausing the game when it's about to lose, right? So these other form of intelligence is called generalized intelligence, and the program will be able to demonstrate or show these signs of intelligence once it has once it is able to show the first five intelligences. All right. So all right. Now, how to achieve AI? AI has been defined in terms of what to achieve, but not how to achieve. So, how do we achieve AI is actually really hard. So, AI is generally achieved by many systems together. Some of the systems could be domain specific computing, some of it could be coming from rule based systems, some of it will be achieving using robotics, and most of it involves machine learning and deep learning. Therefore, machine learning is called the branch of AI, and deep learning is form of machine learning. So this is the areas that we focus on as part of this course. All right. So now next we are going to talk about various kinds of machine learning. Okay. Let me try to answer some of the questions. A question is from Somya. If you used pre-trained models, do you need to contribute it back post further training? Not really. Not really. Okay. It's up to you if you want to keep it to yourself, as well as read through their copyright or the agreements carefully. Okay. Whosoever pre-trained models you're going to use. A follow-up question regarding Google search. Can AI help in prioritizing, for example, a company's brand in case someone search for a car, or does those on the top of the results arise because they are more searched? So there, one of the main algorithm used to be PageRank, but they have mostly capped that as secondary, and it has become mostly based on how useful. First, Google tries to understand how useful is your page content, and then tries to figure out whether and how many people are reading and staying on your page. Okay, so all right, so I'm going to. Is there any topics for big data? Big data, there are no more topics in big data. We had only a couple of slides for big data. And this one. If one learned this course, how much salary? It's hard to answer this question. And just take a look at Indeed or other things. You will get the answer. Just to add on machine learning examples, I believe that ML can help on threat hunting. Yes, there are many examples that there are many more examples of machine learning. Probably everything which we have not even thought. There are such as like zooming an image, zooming out or zooming in on an image is basically now a machine learning task. All right. How to decide if problem falls into automation or AI? Okay. So again, a hard question. So once you know that it can be solved with machine learning or deep learning, you will know the difference between the two, and you will know which one to use when. All right. What are the models that a beginner in machine learning should follow to learn? I would say that one should basically learn regression and classification as much as possible. Okay. How do you exactly track Mario's behavior? Are you tracking events like analytics? But that we need to code for Mario. So the way it is tracking the behavior of Mario in the game is by by considering every data point as the screenshot. Okay, it's taking the screenshot and using that screenshot, it's basically understanding the whole environment. Every pixel on the screen is one column for our data input to the machine learning. How accurate the ML used into the application? Is it possible using ML to teach? The machine learning could make a huge error into the learning process. Okay, so yes, uh, sometimes the ML models have huge errors, and there is no generalized answer. So it all depends from case to case. All right. Okay. Let us say same set of data given to two or more people. Will the machine learning algorithm generated by different people will be same? It'll be different. And it all depends on many hyperparameters. Okay, many organizations receives data on daily basis. So how often ML algorithm should be revised to incorporate new data as well? So it all depends on which kind of algorithm they are using that we are going to come to. The whether batch processing or incremental, that depends on the kind of problem they're solving and kind of algorithm they're using. Can we, as humans, override ML decisions if we know ML decision is not right? Yes, of course, we can override that. And it's a huge debate about whether ML decision is right or wrong. So that's why we will learn things like ROC curves. We will learn about recall rate and precision. And we will have the luxury of choosing between various knobs and various criterias to decide which ML decision would be right for our use case. Okay. A question from Soumya is robotics is a form factor, but the actual learning will be through ML. So why shown separately? Robotics is mechanical device. Robotics is a mechanical part. So like for example, printer is robotics, but it's not AI. Okay. So therefore, there could be many things in robotics which are not related to machine learning or deep learning. A question is how AI builds. So we build AI in parts by composing all these components as I shown you on the screen, like this one. Again, I would love to answer this separately. A question is, you spoke of objectives of AI, which ones are achieved using ML as opposed to the rest of AI. Okay, so all of these are achieved by a combination of physical hardware devices as well as the software. All right. So how we achieve is a separate thing, but the definition of AI was oriented towards the objectives. Okay. Achieving objectives is what was basically the purpose of defining it. I'm curious if there will be ML projects covering the principles behind self-driving car. So we will cover something like image recognition. We will also cover things like reinforcement learning, where we will create Mario-like environment. So if you compose the two, that's basically the primary idea behind self-learning cars. Okay. All right. So I think this is answered, tracking the behavior. So as I described that we take the screenshot from the simulator And that's what, or you can say that we basically take the capture of the whole memory from the simulator instead of analytics. Okay. Okay. This one, all right. How AI builds? We build the AI, not AI builds. And it's not, so the initial parts we'll have to build, and then rest of it it can build many parts of it its own. Okay. But still, it is we who have to design it still. It won't build it by itself. All right, this is also answered. A question of big, what is the what's big scope for ML in near future? So understand this, that what programming did to the usual engineering, as of today, almost every engineering is programming. Okay, as you grow, let's say you are in manufacturing, as you grow in your career, you're going to move to programming, because a lot of work, whether you're doing fabrication, whether you're molding, everything becomes programming at the end of the day. So what programming did to the traditional engineering, that's the same thing being done by machine learning to the traditional programming. Okay. So therefore, I can see that all of the software engineers would learn machine learning in future. A question is, can ML be used for learning large data set CFD data like scientific sense out of data? Yes, that's what is machine learning about. Is CloudX Lab more about learning things, or do we have placement assistance? Yes. So we are not a placement company, but we can definitely help you in things like prepping up your resume, as well as if the people are some recruiters are coming to us, we can just refer your resume, as well as if there is, but we do not guarantee any of this. We're just saying that in case some people approach us, we generally connect them to our students. Similarly, we can involve you in the projects if you show good commitment in solving projects. Okay. I directly came into would like to know to enroll your course you have been mentioning, and you can go to the website and you can find it there. All right. Okay, so moving ahead, great set of questions. All right, so let's move ahead. All right, so let's move ahead, and here we go. Okay, so we are going to talk about various kinds of machine learning. Machine learning can be categorized based on whether we require human supervision or not, whether we are learning incrementally or not, as well as how well they generalize. So these are the three big criterias for classifying machine learning into various categories. So we will start from here after the break. Let's take a break for 10 minutes. Break for 10 minutes. And we'll be back by 11:15 a.m. SGT. Please post time in your own time zone. All right, so I'm back. Should we start now? All right, so let's start with machine learning types, the various kinds of machine learning. You can answer using chat. A question from Pinto is, as mentioned during the course, we don't define rules in ML as opposed to automation, but do we need to tell ML model what are the parameters it should look into? That's correct. That's why we are studying this course, to understand those parts. All right, good question. A question is, as an individual, if I were able to learn, if I were either to learn ML, big data, or AI, what were the possible revenue earning models I have if I were to go about doing it independently? Okay, so you could, there are a couple of okay, it's a hard question to answer. One is, if you are in a job, then you can switch the team or get promotion in the job. If you are looking for a job, then you can get a better job. That is one thing. That is from the perspective of career. Now, if you are an independent person and you're trying to build a product, then you could take a look at, say, the pre-trained model or download existing data, and you can launch your own API, which the world can use for many domain specific work. So you could actually build some domain specific intelligence or AI API that the world can use. So those are the couple of things that come to my mind. A question is, do I need to be very good in maths for learning ML? This particular course, the way it is designed is going to be good adapt. So for this course, you need basics of maths, whatever you learned in, say, a high school. That's all you need. Other than that, you won't require much. If you are stuck at any point, I would love to help you out during the course and would love to start from the beginning of the maths. All right. But that'll be a separate session. Okay. All right. A question is how sensitive the AI ML accuracy can be for hospital and other critical injuries. What are the ways to minimize error and to the acceptable levels? Okay, as I detailed earlier, so when we do these things, we learn how to choose the criteria so that criticality is maintained. So we will learn in the third session where we learn about classification that how do we choose the parameters such that we cater to the critical industries. So we generally choose precision over recall technically. So we'll talk about more detail about precision and recall. Those are the two different criterias for classification. Okay. And just for classification, there would be more and more criterias for other industries. So when we are building any model, we learn what criterias to choose from. Okay. All right. A question is, are ML and deep learning correlated? If yes, can you explain with simple example? So machine learning is a general term. Deep learning is part of machine learning. So in deep learning, whatever we do, we basically learn from where deep learning is basically one particular strategy of solving machine learning problem, and that strategy is using the neural network. All right. Okay, so this one has been answered. How data mining help in machine learning? So data mining has been merged more or less with machine learning, and therefore anywhere in machine learning, we need to mine the data and we need to come up with the insights, and those are basically machine learning. Okay, so what is the relationship between data science and machine learning? Machine learning is part of data science. Data science involve data analytics, data visualization, and others. Okay, all right. Big data concept help in machine learning? Yes, in solving large scale machine learning problems, we do need big data. big data processing. Big data is all about processing humongous data using multiple machines. And that is true even in case of machine learning in certain cases. Like, for example, let's take a case of recommendation engine. Recommendation engine that I built for InMobi was a classic example where big data, that is Hadoop at that point of time, as well as the machine learning algorithms for recommendation, they came together. So big data concept do help in the machine learning in the case of humongous data. All right. A question from Praveen is that in India, other than major MNCs like Amazon, Google, any other industry or areas, are using are they using machine learning? Any examples? So there are many companies. As I am right now in Singapore, I met lots of people here, as well as in India when I meet lots of people. So many manufacturing industries are actually using machine learning at various levels. Many banks are using machine learning at various levels. So today, every company is moving into machine learning because their problems were not solved by writing rules. All right. Question from Robin is, what are the sources of ML models parameters which can be used for reference? The best reference I found is from scikit-learn. Okay. Okay, I'll just type it in the chat window so that you can see. All right. Scikit-learn's documentation is probably one of the mains. Are big data and machine learning correlated? I have answered this already. Great. So great set of questions. Let's move ahead now. Let's learn about the different kinds of machine learning. Let's move ahead and learn the various kinds of machine learning. So machine learning is categorized into three separate buckets. One is based on whether it requires human supervision or not. Second is whether it learns incrementally or not. And third criteria is how they generalize. So let's talk about the first part. So based on whether it requires supervision or not, it's categorized into three buckets: supervised, unsupervised, and reinforcement. So supervised is further classified into the classification and regression. The classification is the training data we feed to the algorithm includes the desired solution called labels. So when we are feeding the data, we also tell that this is our raw data and this is our label data, meaning we teach the program with input and expected output. That's called supervised learning. Say, for example, in case of designing a spam filter, we tell the program that this is an email and this is in spam. This is a proper email, this is in spam, and so on. So we teach we teach the program that this is right or this is wrong. This is X and this is Y. That's called classification. Specifically, it's a part of supervised learning. So classification is the one in which we have labels, right? So classification is basically a supervised machine learning in which we have to label things, in which we have to label things. While in case of regression, we have to predict values. So in classification, the spam filter looks like this, that the spam filter is trained with many example emails containing training data, and each email in the training data contains the label if it is spam or ham if it's not in spam. Okay, so models then learn to classify new emails if they are spam or not. While in case of regression, as opposed to classification, what we do is we teach the model, we teach the model to predict a value. We say, for example, we have, right? Let's say on this, we have the years of the model number, and on the Y, we have the cars. There's a, let's say we want to predict the value of a car, and on X-axis, we have one of the features, and on Y-axis, we have one of the outcomes that we are expecting. Okay, and when we get a new instance, we draw a line on this, we put a feature, and then we try to predict. Let me go back to a proper example. So when we want to predict the price of a car, okay, when we predict the price of a car, what we do is, let's say we have only one feature is the quality property of a car. Okay, so let's say on X-axis we draw, what we draw is, let's say the year of the model. So we draw the value like this. So for this particular year, this was the value. For this year, this was the value. For this year, this was the value, and so on. So we basically draw that. And then when we get a new car, we just ask that, hey, what's the year of the model? And then we draw the dot here, draw a line here, and then we predict the value. So this is basically called regression. Regression is all about finding values, and classification is all about categorizing something into a bucket. Okay, so so we can predict the price of a car given a set of features called predictors, such as mileage, age, brand, etc. To train the model, we have to give many examples of cars, including their predictors and labels. All right, so so basically machine learning, based on whether it requires supervision or not, is classified as supervised or unsupervised or reinforcement learning. Under supervised, we have classification, where we learn how to put labels on something. Okay. And under regression, we learn how to predict a value instead of only a label. All right. Now, how does it do that? How does program work? So the way program would work is, in case of regression, what we actually do is that we draw we try to draw all possible lines. We try to draw all possible lines such that the the line fits the data. That's called linear regression. Linear regression is a kind of regression where we try to draw a straight line. Now there could be many lines that we want to fit into the data, right? There could be many more lines that we want to fit in the data, and and instead of trying all possible lines, what we do is we use a strategy called gradient descent. Instead of trying to draw all lines, we go into the direction that yield better. We change the slope of the line, or we basically shift the line towards that direction which is yielding the better result, meaning which is fitting the data better. All right, so it is basically, what it is doing is it's trying to fit the data better and better. And how it's doing is it's trying to minimize the error, minimizing the error by while we are drawing the line. And all it is doing is it's basically computing the rate of change of error with respect to each of the parameters. And it is basically like you try, if you are blindfolded on the mountainous terrain and you have to find the best lowest point. So what you will do is, if your last step went higher, you will go in the opposite direction. Otherwise, you will just the keep going faster. So all you do is, when you are standing on a mountain and you want to find out the lowest place. What you will do is you will check which side is the slope, and either you will go opposite to the slope or you will further go down the slope. So that's what you will do. Basically, you will try to go in the direction where slope is going downwards. Otherwise, if the slope is going upward, you will turn around and go in the direction where the slope is going downwards. So this is the algorithm that makes the entire machine learning, whether neural networks or whether the normal regressions and fitting the lines, all of that is based on gradient descent. All right. So that was quick, quick insight into how regression works. In regression, we try to fit a line or a curve such that the error is minimized. And to do that, what we do is we basically use gradient descent algorithm. All right. Next one is unsupervised learning. Unsupervised learning is nothing but we have unlabeled data. We have no clue about what is right or wrong, what is the label, and what is it that we are trying to predict. Here, we are only given the data, and the kind of objectives that we are given is classify this data into multiple buckets, or can you compress the data? Can you create a hierarchy of it? So unsupervised, there are many things under unsupervised. One of them is clustering. Clustering is detecting groups of similar visitors in your blog. That's one of the examples. So you may want to detect groups of similar visitors in your blog. They could be based on country, they could be based on other behaviors. And to train such kind of thing, all we need to do is feed the training set to the clustering algorithm, and we provide that how many buckets do we want, and it basically puts your users into buckets. At no point we tell the algorithm which group a visitor belongs to. It finds the group without our help. All right. At the end, you may notice that 40% of the visitors are comic lovers and read the blog in the evening. So the grouping could be based on based on very different criteria than you may have expected. All right. So this data helps us in targeting our blog post for each group. All right. The other example of clustering could be what say Darwin's theory of genetic, the genetic mutation was. So the idea was to classify all the species on the planet into a hierarchical order such that the siblings in the hierarchy are similar to each other. For example, in this, the mouse and the rat are belonging to the same parent. So chimpanzees and humans belong to the same, uh, they are siblings here. Similarly, monkey is closer to the humans and chimp. Cow is little far, and horse and dog are very similar, and so on. So basically, this kind of clustering is called hierarchical clustering. Given the features of animals, or creating a tree such that the animals on closer leaves are closer to each other in behavior. This is called hierarchical clustering. All right. So other example of unsupervised learning could be anomaly detection, detecting unusual credit card transactions to prevent fraud. This could be another example of supervised learning. Now, third example of reinforcement learning, third kind of example of machine learning is reinforcement learning. Reinforcement learning is what we did for Mario. That was reinforcement learning. All right. So based on the human supervision, we divide the machine learning into three buckets: supervised, unsupervised, and reinforcement. In reinforcement learning, we have The examples like Mario, you have the environment, you have the agent. The agent observes and take an action. All right. So this is called reinforcement learning. So reinforcement learning is something that is used very frequently and is very often used in cases like robots trying to learn, trying to walk, even the AlphaGo, in which the el- even the AlphaGo program from Google that defeated the world champion of a game called Go, that was an example of reinforcement learning. Okay, so that was an example of reinforcement learning. Now, that was the classification of machine learning based on whether it requires supervision or not. Now, the other way we can classify machine learning is based on whether we are learning incrementally or we are learning from the beginning. Okay, if we are learning incrementally, it's called online. If we are not learning incrementally, we are learning every time from the whole data. That's called batch processing. Okay, or batch learning. In case of batch learning, we study the problem, train ML algorithm using the whole data, evaluate the solution, and launch. Offline learning or batch learning is the same thing. So system is incapable of learning incrementally. It must be trained offline using all the available data. It takes a long time and computing resources, and every time training happens on the entire data. Once the system is trained, it is pushed to the production, runs without learning anymore. It reapplies or applies what it has learned offline. Now, we cannot train such a system incrementally. We'll have to do it from the beginning. But on the other hand, if we want to learn incrementally, we will have to use different set of algorithms. So learning incrementally or online learning is basically like this. You train the algorithm, you train ML algorithm, you got the data. Based on the data, you train the ML algorithm, then you evaluate the solution, you launch, and then as the new data is coming on the fly, you keep on running and learning. You keep on running the algorithm and learning from new data. Okay, so you keep on augmenting the existing knowledge with the new data that's coming on the fly. So we train system by feeding new data sequentially or in batches. System can learn from new data on the fly. It's good for systems where data is a continuous flow, like stock prices and so on. So using online learning to handle huge data. So basically you have imagine that you have lots of data, you chop it into pieces, and you keep on feeding those pieces into the ML algorithm. So even if you have humongous data and if your algorithm is capable of doing the online learning, you will be able to incrementally learn. All right. So a question from Robin is reinforcement learning the hybrid of supervised and unsupervised? That's correct. That's correct. So it's basically reinforcement learning is essentially supervised learning and might have some aspects of unsupervised learning. Okay. What is the difference between incremental learning and reinforcement learning? In case of reinforcement learning, a very good question. So though the incremental learning and reinforcement learning look alike, the incremental learning is basically updating the existing model based on the based on the based on newer data. While in case of reinforcement learning, what we do is we have the model and we basically apply the model or something called policy in order to predict the next action. Okay, and we gather all the newest steps and learn it from later in the second go. Okay, so though both look same, but there is a difference. So some of the reinforcement learning algorithms, supervised algorithms, or say some of the unsupervised algorithms are incremental, some of them are not incremental. Okay, so some of the reinforcement learning algorithms could be incremental, some of them may not be incremental. All right, how expensive is the online learning in terms of computational complexity? Good question. So we generally use the incremental learning only in the cases where the computational complexity is not much. In case it takes a lot of complexity and it takes a lot of time, then we can't really use that particular algorithm for online learning. A question is, in incremental learning, we learn from every input. What if a new input is an outlier? Doesn't it skew the model? So in incremental learning, it is not necessary that we learn from the every input. We basically fit the data based on the new input. So even if the new input is outlier, then it won't really skew the model if your model is trained for handling the outliers. Okay. Also, while we are doing the incremental learning, we have to keep our eyes open, because if you are, let's say, doing online learning and your competitors know that you are doing online learning, they might try to skew. They might try to put an outlier in the input data to cause to make your program fail. Okay, so you might have to maybe see if the input data coming in is outlier or it's on the similar lines before. In the pre-processing step, you basically try to figure out the outliers. All right. A question is, what is outlier analysis? Outlier analysis is all about figuring out outliers in your data by using, say, clustering approaches, where we cluster the data and see if there are some data which is not fitting in any of the groups. Great set of questions. Keep the questions coming. All right, great. Let's move ahead. So this is called online learning. So it can be used with the huge data sets that cannot fit into one machine. So we can break it down into parts and start training our algorithm in parts or incrementally. So few challenges with the online learning. The system's performance will gradually decline, because if the data is fed, bad data is fed into the system, as question asked by somebody just now, bad data can come from malfunctioning sensors or robots, someone spamming your system. All right. So you have to closely monitor your system in case you're doing online learning, and you should turn off learning if there is a performance drop, or monitor the input data and remove the anomalies in the pre-processing step. Now, the third criteria is based on whether your program is instance-based or model-based. So there could be some classification algorithms which are instance-based, some could be based on model-based. Okay, let us understand the difference between the two. There's a very subtle difference, and looking at an algorithm, you may not figure out which model are you using. Are you using instance-based or model-based model-based machine learning? So most machine learning tasks are about making predictions, right? Having a good performance in training data is good, but true goal is to perform well on new instances. Okay, that's the whole objective, to be able to predict. Okay, that's why we do training. And how well the system generalize on the data it has not seen before is the primary criteria for most of the algorithms. Okay, so there are two things called, one is called instance based and other is called model based. Let's take a look at instance based. Instance based learning is not great. In the instance based, what we do is, let's say we trained our model, we made our model memorize all the instances. Okay, and when new instance comes in, what we do is we compare this new instance with one of the instances nearby and see whether whichever new instance that has come in, which looks similar to the new instance, and then say, okay, let us take this case, right? Here we are saying that we have these instances, triangles and squares. When new instance comes in, whether it's triangle or square, how do we decide? What we do is we find the distance of new instance from the existing instance and according tell that, okay, the new instance is closer to triangle, therefore it's a triangle. Okay, so that's called instance based learning, where we don't have a model. All we do is compare with our data and figure out what is the closest we have memorized. Okay, okay, it's like sitting in maths exam and you have memorized 3 plus 5. 3 plus 5 is 8, and in exam you got the question as 3 plus 4. So you will see that, okay, which one this 3 plus 4 is matching with. If it's not matching with, then pick the one that is closest, and therefore you might end up picking up 3 plus 5. Okay, so the answer could be, for 3 plus 4, the answer could be 8. All right, so this is called instance-based learning. In instance-based learning, all we do is we memorize the various instances types, and then when a new instance is there, we see which instance is closer. So it's a most trivial form of learning, and we basically learn from by heart. The system learns the example by heart and memorizes it, and then generalize the new case using similarity method. Okay, the example could be there are so if we know the known spammers, right? No spam emails. We could say that, okay, these are spam and this is a normal email. And when a new email is there, we compare the new email with both the spam as well as non-spam and see which one it is closer. So that is called instance-based learning. While in model-based learning, we figure out a model, we figure out a line, a curve that separates our spam versus not a spam. Here we are we are separating the triangles from squares using this line. Now, once we have the model, we will ask the model that, hey, does this new instance lie on the triangle side or on the square side? So this is a better way of prediction, because instance-based learning doesn't work very well. All right. So that is about instance-based and model-based learning. All right. Great set of questions. So moving ahead, I'll answer your questions in a minute. Now, so that was the classification of machine learning. Now, there are many ways or many algorithms to solve machine learning problem. One of those algorithms are based on artificial neural network. So this is the computing that is inspired by animal brain, inspired by the biological neural networks that constitute animal brains. Okay, so what we do is we basically feed data into these units that mimic the behavior of neurons, and they learn based on our output expectations. So mostly the although you can do unsupervised learning using neural network, but you can do the supervised learning very well with neural network. So I'll go into details as in how it works in a minute. Okay, so basically with artificial neural network, we learn to improve performance, to do tasks by considering examples. Okay, generally without task specific programming. Okay, for example, we may want to figure out whether it's a cat or a dog by looking at an image. So that is really complex work, that looking at an image to figure out whether it's a cat or a dog, or cat or not cat, or figuring out that which breed of the dog it is. So that is basically the role of ANN. Artificial neural network basically help us do supervised as well as unsupervised machine learning in order to do really complex tasks. Now, let me take a very simple example. We all take bath every day, right? And specifically in winters, we have we generally want to take the bath in warm water, right? And every morning what we do is we have this knob. If we turn it to the left, it'll be completely hot water. If we turn it to the right, it'll be the cold water, right? And every time what we do is we turn on the knob and put our hands in the water. Generally, we start in the middle, and we generally start in the middle, and we touch the water and check if it is warm enough. And if it is not, if it is colder, then we turn the knob to the left to take more hot water, right? And if it is really hot, then we move a little bit to the right, and that's what we keep on doing. So finally, based on our expectations, finally, based on our expectations of water, we will be able to figure out a position of the knob, which is most suitable to us. Okay, so this is what the role of a neuron in computing is. So the way we design our structure is that we have many such neurons in our programs that are connected to hot water, cold water, soap, and so on. And we are trying to find out the positions of this knob, just like we did just now to figure out the hot water for taking a bath. Similarly, we could be figuring out the hot water for just cleaning the clothes or something. So more and more input parameters we put into it, there will be more and more knobs, and that will give us the expected result. So the way, given an output and giving the inputs, we figured out a position of the knob which gave us the correct result, right? This is essentially training a neural network. This is essentially training a neural network. So in a classic neural network, we have many such knobs, maybe tens of thousands of knobs, which are basically automatically the program is tweaking them so that to find a combination of the knobs, find the combination of knob positions, such as it converts the input into the output. All right, this is essentially the each neuron, but we can actually create many layers of such knobs and really process complex data. Okay, so here this is a single neuron, but here you can see 1, 2, 3, 4, 5, 6, 7. So these are 7 neurons, and here this input layer is hot water, cold water, maybe soap, maybe the person's name, maybe the weather condition. Those are the input layer. Okay, and here the output layer, in this case there is only one output expected, called the output is the yes or no of whether the temperature is okay. Here we have 4 outputs. So in a classic neural network, we have one layer designed for inputs, one layer designated for outputs, while we have only one layer as hidden layer. This is called hidden layer, input layer, output layer. Okay, this is output layer and this is input layer. Now, there could be many hidden layers, like in this example on the right hand side. This is called deep learning neural network. Why? Because it has more than one hidden layer. So if your neural network has more than one hidden layer, it is called deep learning neural network. All right. So there are many companies as of today using neural network, and it is more often than earlier, because right now doing the neural network processing is very much possible. It was impractical 10 years ago, but it is very much practical now. All right. So many companies like BuzzFeed is generating its food feed, as well as Airbnb is using for price prediction and everything. The Optimizely is also comparing the images and so on based on the neural network. Google, Pinterest, and Facebook, all of them are using deep learning to do various predictions. The most recently we had this Google Translate as well as the auto draw. Okay. So you can take a look at more use cases here, AI experiments with Google. All right. You can take a look at that. Now, further, you can see how to train a neural network based on neurons. Let's say this is our data and we are trying to draw a line such that it separates one color from another. Okay, we are trying to generate a model such that it separates one color from another. Okay, so we could add more and more layers to it. Okay, and then we can start the where is it here. So it's just trying to figure out, you can see it has figured out that, okay, there is a circle that divides one color from another. Okay, so basically you could take a look at that one. Look at Google's playground. We will also be doing similar thing as part of our deep learning. So we'll be building all kinds of systems using the various architectures of deep learning. And there are many deep learning frameworks, starting with TensorFlow, Theanos, Keras, Caffe, and PyTorch. We have chosen TensorFlow because it has got the maximum adoption in the industry. Similarly, the usual machine learning frameworks like MLlib, scikit-learn, pandas, and other things, we will touch base upon these in the course. There are many courses available on the internet. There are self-paced courses like Coursera. And what we have is we have a combination of both. We have the self-paced recorded video-based course as well as the live course with us. Okay, our course has been pretty successful in past, so please take a look at the reviews people have given us. So feel free to let us know if you would be interested in the course. All right, now let me go back to the questions and try to answer. A question from DP is model-based training the curve could have been different if X has been square in the test data? In the model-based training, yes, the curve would definitely change if you square either of the axes. Okay. A question from Benjamin is that are time-based regressions like online learning? Not really. So it all depends. Time-based regression, time series-based regression could be like you want to predict the stock prices and so on. Those we will be covering in this course under RNN, recurrent neural networks. All right. Question from Seeker is, what are the use of connections between neurons? Significance of many to one connections. Many to one connections, yes. So it's taking the input from many and learning from that and then giving the output. Okay. So what we're talking about here is this part. The question is, what is the significance of connecting this neuron from all of these? So essentially, this one is an output of combining all of these. This one is an output of combining all of these, and so on, right? So there are many, many more neural networks possible. Some, there are like CNN based convolutional neural network in which each neuron doesn't really connect with all of the other neurons. Instead, it stay focused on only few neurons. That's basically the idea. So even though here we have fully connected neurons, but in certain architectures, it is not. Okay, so there is no hard, there's no really only one way of doing the neural networks. All right. Next question is, can machine learning problem be solved by Spark? Yes. If your data is humongous and you need scalable computing, then you may use Spark's MLlib. MLlib is provided by Spark. Okay. A question from Ziva, what are the ways to package models other than pickle library? Okay. So there are quite a few ways. One general way is you just export the data in a transparent manner such that you can write your own deserializer and create it in any other language. Say, for example, you could save the result of all our work as text data in the form of JSON, and then you can take that JSON to the mobile device and reload it and run it there. Okay. Question from Dinkar is, can you please explain the concept of recurrent neural network? In recurrent neural network, we feed the outcome of a neuron back to itself so that it can remember the past. Okay, that is the core idea about recurrent neural network. Question from Jetus is, give me some more examples of neural network based use systems. So there are many examples actually. Wherever the answer is not straightforward, it is generally fed to the neural network. All right. So there are many examples as of today, even like Google Translate, all of the systems that you see are generally based on neural network. What is the use of score calls and schema files? Okay. Could you give me a bit of context? Question is, what is the pickle library? Pickle library is basically a way to save the object into the disk in Python. All right. Great. So reach out to us at research@cloudxlab and come over to our discussion forum for more questions. Also, please answer give the feedback in the form that we have filled. Okay. All right. A question from Chetan is, can you give example of multiple hidden layers neural network? So there are many examples of multi-layers. Also, it might vary from problem to problem. When you are solving problem, you generally start with one layer, then you keep on adding more layers and so on. Okay. So example could be convolutional neural network is an example of multiple hidden layers. Okay. A question is, let's say I train a bot over the training set. How is the training saved in the memory? If you are training a bot over a training set, yes, how is the training saved in the memory? Training is saved as numbers. The way when we were tweaking the knob, it was the position of the knob that was the learning based on the temperature of the water, right? So similarly, the training is saved as a model, and that model could contain numbers. Can you please suggest some good reading books for machine learning? The one that is quite popular is from the the deep learning one. Okay, I'll share the link. Okay, I'll share the link in the email probably. A question from Eugene is, do you cover neural network adversarial attack in the course? How, both how to improve and an immunity to generate to it or generate tainted input. All right. So we have not covered a neural network adversarial attack so far in the course, but we can take a look. All right. We can give a brief into the course. A question from Dinkar is, by looking at problem statement, how can we identify which algorithm to use? There is no hard and fast rule to this. We basically start with a simple model and then try to make it complex. And if it is not if it is performing well, then we basically fine tune the model. Okay, instead of switching between the models. If the model is not performing well, we can see that, okay, the performance is coming like 50%, then we have to tweak it. All right, we have to move to another algorithm. So based on whether you are doing supervised learning, unsupervised learning, classification, or regression, we choose certain algorithms. There are many algorithms under each bucket. In LSTM being used to solve many problems. Yes, LSTM is being used to solve many problems, and we cover LSTM in one of the chapters. Question is, could you explain deep learning again? So deep learning involves neural network of multiple layers, multiple hidden layers. And okay, so yes, deep learning is part of the course. A question is there a standard limit for hidden layers? No, there is no standard limit. Your number of hidden layers or number of neurons are limited by the memory of your computer. All right. I'm going through Azure ML model management. When we deploy models or expose a web service, we need to pass scoring scripts, and it also accepts schema JSON file. If you have any idea, this is very Azure specific. Take a look at that one. Okay. Question from Ajit is, what is next after deep learning? So there are many hypotheses around that, but deep learning is, yeah, there is a huge scope in deep learning. Okay, there's a huge scope in deep learning. All right, so that's pretty much. So thank you, everyone. It was wonderful set of questions. I thoroughly enjoyed your question. Please feel free to let us know how did we do. Thank you, Robin. All right, sure. Let me see if we can extract the question answers from this discussion. Okay. Sure. Thank you, everyone. I thoroughly enjoyed your question. Sure. We will share some of the books over the email. What are the limits of deep learning? The limitation is again based on CPU and memory. So that's basically the limiting factor of deep learning. Okay. All right. A question is, can you give some advice on improving GitHub and Kaggle profile you suggested? I would say that you start competing and start committing the code into GitHub, and rest will happen automatically. We have a lot of homework, but not for today. But in general, we have a lot of homework in our classes. All right. So it was wonderful to have all of you in the session. Great set of questions. And yes, personally, we try to keep the first session to be as generic as possible. Okay. But we can't keep everyone happy every time. Therefore, This is basically a trade-off. All right. Thank you, everyone. I thoroughly enjoyed your question. Please feel free to let us know if you have more questions. A question is, any next sessions are you planning? Yes, next session is coming up on big data, and the course is there. Let me just show you the course. Okay. You should take a look at, say, CloudX Lab here. And okay, so take a look at the view details. Feel free to sign up because there are only few seats left. And yeah. Okay. So this is the course that we were going to launch. We're going to start with introduction to Linux, Python, hands-on with Jupyter, and then overview of linear algebra, and then introduction to NumPy and Pandas. Then we'll have quizzes and examples and projects. Afterwards, we are going to discuss a basics of statistics, and then we are going to start with machine learning end-to-end projects. Okay. So actually, these two will be part of this end-to-end project. We will start right away with building end-to-end machine learning project, and then we will move to classification, training the models. Then we will do the support vector machines. These are something that is required. We'll talk about decision trees, then ensemble learning and random forest. Then we'll talk about dimensionality reduction and quizzes, gamified assessment and projects. Afterwards, this is where we start deep learning. We start with introduction, then TensorFlow. We teach you TensorFlow, and then we teach artificial neural network. Afterwards, we learn how to train a deep neural network, then CNN, then RNN, then encoders, autoencoders, then reinforcement learning. So this is the general course. Take a look at this. If you have more questions, please let us know by sending an email to this. All right.